Hello, so today's video is going to be on repeated percentage change, and that's sometimes known as compound interest or depreciation, depending on whether or not that is a percentage increase or a percentage decrease. I'm going to split this into two videos, and I'm just going to talk about compound interest today. So in order to access the content that we're going to cover today, you need to be able to find percentages of amounts, do some percentage increases, convert between decimals and percentages, and vice versa as well. And you also need to be able to use powers or indices and roots as well. And if you can do all of that, then you'll be able to access this grade 4/5 GCSE topic. So I've got 4 examples, and if any of the questions you are looking at kind of look similar to the ones on my question generator here, then those are the types of examples that we're going to go through, and they might be useful to you. So 4 examples. So the first one, Chris invests £3,900 in a savings account for 3 years, and it earns compound interest of 5% per year. Now, interest is basically the money that a bank gives you, pays you to look after your money. So you can earn money by putting money in a bank account, earn some extra money. That's all the interest is. Now, what a lot of people do here is they would just find 5% of 3,900 and then multiply that by 3 because there's 3 years, and then you would add that on to 3,900. However, if you did that, you're actually doing what's called simple interest. Simple interest doesn't change year on year, whereas compound interest does. So you need to watch out for these sorts of questions. It says in the question it's a compound interest question. Now, there's a long-winded way of doing this, which I'm going to show you to start with, just so that you can see exactly what's happening, and then I'm going to show you how we can use multipliers to work it out quickly. So Chris has £3,900, and he's going to invest that for 4 years. So year 1, 2, 3, 3 years, and at the start of year 1 he has £3,900, and then what we're going to do is we're going to work out the interest, the money the bank are going to pay him that year, and then at the end of the year we're going to find out how much money that he has. Now, the interest is simply 5%, the question tells us, of whatever he has at the start of the year. So you can work out 3,000, you can work out 5% of 3,900. So if I use a calculator to do that, 3,009, I'm moving the calculator, that's why. So if I use a calculator to do that, 3,900 divided by 10 would get me 10%, divide that by 2 would get me 5%, so that would be £195. And then all you're going to do is, if you add to that whatever he had at the start, 3,900, that's going to tell you that at the end of the first year he's going to have £4,095. Now, whatever money he has at the end of the first year becomes how much he starts with at the start of the second year. So now what I'm going to do is I'm going to find 5% of 4,095. Now, 5% of 4,000, to find 5% of a number, we divide it by 20, and that's going to be £204.75. Then you can see that interest is different to the first year's interest because it's compounded. We're actually working out 5% of 4,095, not the original 3,900 that he put into the savings account. So that's my interest. I'm now going to add to that 4,095, and that tells me that at the end of year 2 he had £4,299.75. So now at the start of year 3 This amount is £4,299.75. Now we're going to work out 5% of that. Now, even though it's with money, we only do 2 decimal places. Because we are not yet at our final answer, I'm not going to round that. So that's the interest he earns in the 3rd year. And now we're going to add that to the £4,299.75. So this tells me £4,514.7375. Now, this is how much money he has in the account, but you need to just double check the question. Sometimes the question might ask for how much money he has in the account at the end of the 3 years. This one actually asked for just the total interest, not the total amount that he had. So this is how much he has at the end of the 3 years. The interest is how much extra money he's got on top of the 3,900 that he originally put in. So we're now going to do 4,514.7375, and we're going to take away from that 3,900. So I'm going to use my calculator. That's still in my calculator from the last time. So 3,900 was the original investment. So his total interest, let's get rid of the calculator now so you can see what I'm doing. If I can find my mouse. The total interest is then simply £614. Now this is our final answer, we can round it. So that becomes 0.74. Okay, so that's the long-winded way of doing it. If you understand what you are doing with, if I just copy this actually and scroll down, put the same question in. Okay, so if you understand what you are doing with multipliers, that makes it a lot easier. So 3,900 is Chris's original investment. Because it earns 5% per year, we're doing the original 100% and we're adding 5%. So at the end of each year, he has 105% of what he had at the start of that year. So we can actually convert this to a decimal by dividing the percentage by 100. So instead of finding 5% and adding it on each time, what we can actually do is multiply it by 1.05. Now multiplying it by 1.05 would, the 3,900 by 1.05 would tell me how much he has at the end of the 1st year. The answer to that, so what we get to this, becomes what he has at the start of the 2nd year. So to find out what he has at the end of the 2nd year, I'm just going to multiply it by 1.05 again. Let me move this out of the way. So this is how much he has at the end of the 1st year, at the end of the 2nd year, and then at the end of the 3rd year, we're simply going to multiply it once more by 1.05. So what you can actually do is if I multiply this by 1.05, 1.05 times 1.05 times 1.05 is the same as 1.05 to the power of 3. So we can actually do, where's my calculator? We can actually do 3,900 times by 1.05 and then press the little power button, and in there we can put 3, press equals, and that tells me that he has £4,514. Because this is how much money he has at the end, we can now round it. Now that there, remember, is the total amount. This question again just asks for the total interest, not the total amount he has. So what we can now do is just take away the original amount, which was 3,900, press equals, and that tells me that the interest was £614.74, which is the same as, if I get rid of the calculator so you can see, which is the same as what we got earlier. So this is the quick way of doing it, and this is the way that I'm going to be doing it for the remaining examples. Okay, so this time for the second question, we've got Tony investing 2,900 in a savings account for 11 years, and it earns compound interest. For the first 6 years, the interest rate is 6%, and then it's 2% for each year after that. So what we want to do is the initial investment, and then we're going to multiply it by the multiplier for the 6% for 11 years. So the original amount is 100%, remember. Because it's an increase, we're going to add 6% to that. So that tells me that at the end of each year, he will have 106% of what he had at the start of the year. So this, as a multiplier, becomes 1.06. So I could multiply it by 1.06, and then times that by 1.06, times that by 1.06, and do that 6 times. Or I could put the 6 there, because that's the number of years that we get that 6% interest. After that, what we are then doing is we need to, if I just get rid of that, we then need to multiply it by the 2% for the remaining years that money is in the account. Now, because we had 11 years in total, and the first 6 have got an interest rate of 6%, that means the difference between the 11 and 6 is how many more years that money is in that account. So what we are now going to do is the 100% plus the 2% becomes 102%, which as a multiplier is 1.02. So I'm going to multiply this by 1.02 to the power of 5, which is those remaining years. Okay, now finally, this is a calculator topic. So I'm going to do, where's my calculator gone? There it is. The initial amount, which was 2,900, multiplied by 1.06 to the power of 6, multiplied by 1.02 to the power of 5. So over to the calculator, 2,900 times 1.06 to the power of 6. Remember, so your little cursor here is flashing just next to that power. So remember, now we need to move over to the right, and then we're going to times that by 1.02 to the power of 5. And again, this gives us the total amount at the end of 4541.86. Okay, so that's the total amount. Sometimes the question will stop there. However, this question again just asks for the total interest that we've earned, that Tony's earned. So now what we need to do is we need to take away from that the original investment, and that will just tell us what the profit was, or the interest when we invested that money. So I'm taking away the 2,900, and that tells me that I have or Tony has earned £1,641.86. Okay, 2 more examples. Okay, so this one here, you are told how much Tony has at the start, you are told the interest rate, and you simply need to work out how many years, after how many years his savings account will be worth at least 5,246. So all you're going to do with this one is the original amount, 4,300, if you multiplied that by 1.03, because it's an increase of 3%, and that 103% as a decimal is 1.03, that would tell you how much he has at the end of the first year. So what we're going to do in our calculator is, we might as well just make a note of that's year 1. So what we're going to do in our calculator is we're going to do 4,300 and we're going to times that by 1.03. So at the end of the first year, he has 4,429. Now, you could write out this again and then times it by 1.03, but your calculator has this function where it stores the most recent answer. So if I then press times again, press the wrong button, if I then press times again, 1.03, the answer we've got stored in the calculator here is that 4,429. And remember, that becomes what we had at the start of the second year. So if I press equals again, that tells me how much he has at the end of year 2. So I could just write 4561.87. Now remember, we're looking for the first year where he has a minimum of 5,246. So now every time you press equals, that's going to give you how much he has at the end of the next year. So at the end of year 3, he has £4,698.73, and then we're going to press it again for the end of year 4, £4,839.69, and then year 5. You can write them all out, but as long as you keep track. So that's year 5, year 6, year 7. So year 7 is the first year. If I just keep going down, year 7 has £5,288.46. That is the first year where he has more than £5,246. And that's it. Okay, last example. If I clear the calculator. Okay, so for this one, we are told what Danny got at this, how much Danny invested at the start, how long it was in there for, and at the end of the 7 years, how much money was left. So, with these questions, we know that 3,700 multiplied by the multiplier, but we don't know what that multiplier is. So remember, your multiplier, if something was increased by 5%, would be 1.05. That's not what x is in this case, but it's going to be something like that. Now I know that if I multiplied it by x 7 times, I would get the answer of 5,206. So actually what we can do is we can multiply it by x to the power of, not squared, to the power of 7. That's simply the number of years. And when I multiply that original amount by x to the power of 7, I get £5,206. Okay, so now we're just solving this equation. In order to find out what x is, I need to first find out what the x to the power of 7 is. So to do that, if I divide this side by 3,700 and I divide this side by 3,700 as well, that's going to tell me what x to the power of 7 is. So let's just do that. 5206 divided by 3,700. So that gives me quite a nasty fraction. So I know that x to the power of 7 is 1.407027. Now, in order to find what x is, the inverse operation to doing something to the power of 7 is to take the 7th root. So I'm going to take the 7th root of both sides. The 7th root is just the same as the squared root or the cubed root. It just means what number multiplied by itself 7 times gives me that nasty decimal 1.407 and so on. So using our calculator, I'm going to clear it, but remember that calculator has stored the most recent answer, which was that nasty decimal. Just above the x to the power of button, I can press shift and then I can click on that one, and it brings up this root, but I get to put in the power that I want. So I'm just going to put in 7, because we're trying to do the 7th root, that's the number of years, and then I'm going to press the AND button, which has stored the answer from the last one, and that tells me that x is going to be I'm going to do this to 2 decimal places, 0, 5. So that tells me, oh, it was 1.05 after all. That tells me that each year, at the end of each year, I have 105%, because this is as a percentage is 105% of the original amount. Be careful here, because this question is asking for the rate of interest. So this 105% includes the original amount, which is 100%. So the interest rate is going to be 105%, take away the original 100%. So each year, Tony, I think it was, sorry, Danny in this case, is getting 5% interest. Okay. Like I say, I'm going to do another video on this one with depreciation, which is where the percentage is less than 100, so it decreases, and that happens multiple times. I'll do a separate video with that one. But let's go back to the question generator. So the questions we've done today are just this repeated percentage increase. As always, when you open this file, you'll need to click Enable Content in a little yellow ribbon that appears at the top. If you don't do that, then the question buttons, all the buttons in the file won't work. So as always, you can generate questions of increasing difficulty. If you are feeling brave as well, you can have decimal percentages. So for example, 2.5%. Rather than whole number percentages, which is what I've covered today. You can try a particular type of question and generate new questions, or when you're really confident, you can try a mixture of them all, and when you do that and you're getting them right, that kind of demonstrates that you've kind of got to grips with the topic. So that's it. I will put a link to this file in the YouTube description, so you can download a copy and practice on your own. But other than that, thank you very much for watching, and I'll do another video on the repeated percentage decrease shortly. Thank you, bye bye.